I get to that is just realize this. We have good, we're lecture, a little homework. We have only 3 weeks left in the semester. We have this week, next week, and then the following week after that is final exam week. For those of you not used to final exams, basically you have only 2 or 3, maybe 3 classes a day, and usually it's a less than a full day that you would have class, but you have a final exam, which is basically the summation of what you had learned during the semester. It might not be as in depth as some of our tests and quizzes would have gone, but it would have the overall gist of it. I think for algebra, I think that your final exam is worth 15% of your overall grade. And so it's definitely something don't allow your final exam to drop your grade. Definitely a blank exam is the easiest to grade because there's nothing to grade. But put forth the effort on any one of them you take, because your final exam can indeed influence your overall grade. Yo. Yeah, it's coming. Can't tell you the exact day, but it'll be before the final exam comes. It'll be coming your way. So you can take a look at that. We will definitely have some times to review. Yo.
Are there like multiple days in a row we'll have the test, like in here, like let's just say I have the math test 2 days, but then
I think
it's just one a day for every class.
Well, I can't speak for every class. This class, we're just going to have the one day that's assigned for us for the final. There's other classes in the math department as well as other classes in general that might have a first portion you would take prior to that, and that's something that those departments have chosen to do, and it's totally appropriate. But it's one of those. If you are the person who's never does anything at home, there's a reason why it's called homework. It's because you're supposed to do it at home. There's practice opportunities to do it. And I know that some of you will choose not to do it, and you'll try and cram it all together during class, and then you get frustrated because your grade isn't at the appropriate level that you'd like it to be. So I would just take it upon yourself. I mean, you have 2 weeks off after these 3 weeks, so put it upon yourself to say, you know what? No, I don't want the 78%. I want to get the B in my class, or I don't want the 68%. I want the C, or 88%. I want the A. Whatever. So take it upon yourself to put forth that good work ethic to bring yourself to the appropriate grade. If you are like going into a final exam with an 80% exactly, chances are you probably will get a C. Okay, and you're like, well, that's not fair. Well, it's because you didn't prepare for it. It's very fair. But don't allow yourself to be a borderline grade and expect you to come out with the higher of the grades with a final. And I'm not trying to say that to scare you. I'm just trying to give you the reality. It's pretty rare that a student goes into a final and brings up their percentage by a significant amount. The opposite end of the spectrum, I've seen people just, I don't feel like doing the final, and they, if it's multiple choice, they write AC/DC all the way down on their bubbles going, yeah, I'm sure it's a pattern. They turn it in, then your parents call going, well, I don't understand why they do so bad. So, well, they bubbled AC/DC all the way down, and that wasn't the pattern that we were looking for. And then usually the parents will say, well, can they retake it? No. So take it upon yourself. Do well on it. Just saw a memo that came out. There's no early finals to be given. If you are going to miss, for whatever reason, your final exam, or you happen to miss that day, then the Friday after we get back after the new year, in January, that's when you can make up your final. So that's kind of a school-wide decision. It's not based on a department. That was a directive that came from the principal. So I just want to give you guys a heads up, and I don't want to scare anybody. I just want you to, prepare for a test, and it's a good test. Don't wait until 30 seconds before saying, hey, I have questions over these 18 items. There's not time before the test to do that. So let's talk about linear functions and inequalities. This goes along. We're still going to be graphing lines, but what we're going to do now is we're going to shade regions either above or below the line when we do graph them. And so I know that you all are able to graph. I know that some of you struggle with some of the point slope graphs. You didn't realize how to pull the point out and then use the slope. And, you know, it is what it is. Just do not allow yourself to, don't allow yourself to get through this unit not understanding how to graph. Come see me. Come see, get extra help in the math science resource room if you're not sure how to graph. I mean, don't just fizzle along going, oh, I'll eventually absorb it. You need to practice it and get it. So a linear function and inequality. The inequalities are used often in industry to figure out maximum amount or minimum amounts of consumption of products. We actually just, I thought it was kind of silly. We flew Frontier Airlines back from Florida. It was a direct flight, which was fine. It was like 3.5-hour flight from Orlando, Florida to here. But there was really, other than the safety card to tell you where all the exits are, there was nothing else in the seat back. There wasn't like a magazine. There wasn't extra video screens. And we'd asked the person who was, you know, coming by and trying to sell you a can of soda for, you know, $3.50, or you could, here, I'll pour you a little bit of water, and this should help you. But we asked, we're like, you know, there's no magazines or anything, you know. Usually there's some sort of Sky Mall trying to sell you crap on the plane. But they're like, oh no, we Frontier Airlines realized that it's a weight issue, and by us not having the extra 50 pounds of weight, we're saving so much money. And I thought, 50 pounds of weight, okay, I guess I get it, but also on the other end of the spectrum, there's a part of me that says, you kind of want to try and entertain your customer. Now, I flew Southwest going out there. I don't know if you've ever flown Southwest, but it's kind of it's a joke how you herd onto the plane because it's not assigned seating. But when you get on the plane, you can get on your electronic device, and you can, if you uploaded their app, you can watch television shows and movies, and if you decide to, you can pay like $3.50 for your flight, and you can actually get on the internet, which it is what it is. But I thought, you know, Southwest has it figured out pretty nicely. Frontier, there's a reason why they just closed 5 of their gates at DIA. I think they suck as an airline. They don't, you know, I don't know how hard it is to look at Southwest going, what does Southwest do that we could mimic? Oh, how about we charge more? Wait a minute, when we charge more, people aren't flying us. Duh. So an inequality is, you know, greater than and less than, kind of a business model. Sometimes companies are doing well with it, but basically what we're going to do is we're going to figure out how to graph a line. Sometimes be that, sometimes be dotted, sometimes you can shade on top of it, sometimes you can shade on top, or you can shade on bottom. You know, it just depends how it goes. So these are just regular graphing problems. These are similar to the ones we've done. First one, we have y equals 2x minus 3, so I graph the negative 3 at first. So that gives me 0.0, negative 3, and the slope is going to be 2. So I go up 2 and right 1 from there. And theoretically, I could continue going up 2 and right 1. But you only need 2 points to define a line. So your first one will look like that. Your second one, you know that 0, 5 is your y-intercept. 1, 2, 3, 4, 5. And then from there, you're going to go down 1, right 2. And you connect those dots, and you create both of those lines. So this is just review. Those were both in slope-intercept form to go with. So then we're going to start incorporating the linear inequality. So we've done these before. Basically, how you'd solve this problem is I just have x on both sides, or one side. So I'd wind up with a problem like this, and then I'd divide by 2. So I'd wind up with an answer of x is greater than 3, which means on a number line I'd have 0, I'd have 3. I'd have an open dot because it's not equal to, and we would shade in the direction that we need. So I need values bigger than 3, such as 4 and 5 and 6 and 7, or 3.01 or 3.0001 or whatever. So that's how we would go with the basics of the linear inequality. But now we're going to incorporate this into using the xy axis. Remember, the xy axis are just 2 number lines put together. So what about if I had 2x plus 6y is less than 12? These are linear equations. They have an inequality sign, so we have to divide the graph into 2 halves. So if I have a line that's graphed on the xy axis, let's say it looks like this. That's not saying that problem looks like that. But there's a bottom portion of this graph and there's a top portion of this graph. And there's only one of those regions that's going to hold true for this problem. And I think one of the reasons we teach inequalities on basic level is we've all been to the grocery store and there's the 15 items or less lane. You guys have probably seen this if you're with your folks in the store. And it gets a little maddening where you want justice served on the person who steps up to the lane with 18 items. Like you want them to get run over in the parking lot. You don't want to deal with them. You're mad because you want to buy a pack of gum and they want that, and then they want to write a check, and it's like they've got dyslexia and they can't write a check out any longer. You're like, oh my gosh, you got to be kidding me. But so the needless to say is they want us in this type of problem is they want us to verify if 0, 1 is indeed a solution to this problem. And a solution would mean if I plug those x and y values back into the original equation, the equation reads true. If it reads false, it's not a solution. So 0, this is x, y, so I have an x value and I have a y value. If I take these x and y value and plug them in, and see if it holds true. So I realize that my x value is a 0, and my y value is a 1. If I plug these values in, it becomes 0 minus 3 is less than negative 2. Is negative 3 a smaller value than negative 2? Yes. So is this a solution to the problem? Yes. Make sense so far? Some of you aren't paying entire attention. I'm quite sure I haven't figured out how to play this class yet. But okay, so if we want to graph this equation, so I think this is the same equation we just had. 2x plus 6y is less than 12. Yes, it is. We do know from this last problem that 0, 1 was a solution. So I'm just going to write 0, 1. We already know that's a solution to the problem. That's part of the problem set that works with this problem. Okay? How is this problem set up? How could I graph it? What method could I use to graph this that was really straightforward, had nothing to do with math, easiest one to think about? Forget it. Cover method. So that means I'm going to cover up the 6y, so I have 2x is less than 12. So if I get 2x equals 12, what's x equal to? 6? Right?
Yeah.
Okay. 4, 5, 6. Okay, there we go. And then if I cover up the 2x, I get 6y is equal to 12. If I solve this, what is y equal to? 2. So again, in the y direction, I go to 2. And would you think this would be a solid line or a dotted line? And what might stick out? What do you think? It would be. Why? There's not an equal sign on the other side of this. So I don't have this is less than or equal to. So this is going to be a dotted line. Oops. Ooh, okay? And remember, we originally had said that this is a solution to the problem. So what if that means that you feel that this red is underneath the line or is it on top of the line as it sits? It's going to be underneath it. I'm going to erase this other portion. It's definitely underneath it. So I could pick any point. I could pick this point right here, which might be -6, -5. And if I take that and I plug it in, being that this is underlined, this should also hold true. So again, this is an x portion. Here's a y portion. If I plug those in, I get 2 times plus 6 times is less than 12. 2 times -6 is negative, and then 6 times -5. So I'm going to get -12 plus -30. Is that less than 12? Well, -12 and -30 combined together gives me -42. Is -42 indeed less than 30? Yep. Gage, wake up. Okay, so with that known, that means that any of the points that I pick underneath the line itself are a solution to this problem. So there's a whole region to this graph that's going to work out. Okay? And that's how we go through this problem. So a basic, easy way to run through it is graph the line, and then if it says shade the appropriate region, you have to pick a test point. So if you have a line picked, pick a point that's way away from that line. Don't pick some decimal or fraction amount. Pick a whole number of values. a lot of times 0, 0 would be really easy to pick as long as the line doesn't go right through 0, 0. A lot of times 0, 0 is either above the line or below the line, because a lot of times our line won't go right through the origin. So sometimes 0, 0, or a lot of times 0, 0 might be a good choice for us. Question?
How do you decide if it's positive
Oh, okay. Let me go. Let's go to the very end right here. So if I have this or this as my symbol, it's going to be a dotted line. And if I have this, where I have the line underneath it, that's going to make it a solid line. Does that make sense? Okay. So number 6. So y is less than or equal to 2x minus 5. So what do you think? Is this going to be a solid line or a dotted line? What do you think, Mr. Kruger? Solid or dotted? Huh? Solid line, yeah, because you have the underneath. So this is going to indicate it's going to be a solid line. Okay, do I know what point to pick right now? No, but I'm thinking in the back of my head right now that 0, 0 might be a good one to pick, but let's graph it first to take a look. So where would this cross the y-axis, and how do we know? Yeah, that's where it's going to cross the y-axis. So 1, 2, 3, 4, and 5. And then the slope is what? 2. So that means from here I'm going to go up 2 and over 1. And we said it was solid or dotted? Solid. So let's ask this. Does 0, 0 seem like a good point to pick? Is it definitely on one side of this line or the other? It is. So I think 0, 0 is a really nice one to choose. So 0, 0 will be our test point. And again, if it goes right through the origin, don't pick 0, 0. Pick another number. Pick like 10, 0 or 0, 10 or something like that. Something that's not going to go through our point. So 0, 0 is that. So I'm going to take my equation. I'm going to go 0 is less than or equal to 2 times 0 minus 5. Is 0 less than or equal to 0 minus 5? What's 0 minus 5? Negative 5. Is 0 less than negative 5?
No.
No, this is false. This is a false statement. That creates false. So everything above here is false. That means that I'm going to shade everything down here. And you can get all nice and neat. It gets kind of maddening during a test when you got the kid that's, the rest of you are trying to work, and you got the one kid. Mr. Stubb, I need more time. Okay. And then you always get the one kid going, oh, I shaded the wrong side. And so they have the eraser that is just about to the metal on the pencil. And then you get the metal scratch across the paper. And you're like, you're sitting next to him going, dude, I can't do the fucking chip thing. Woohoo! You don't like that sound? You guys know what I'm saying? Mr. Summers.
So it doesn't matter if it's true or false. So if it's false, does it go on the bottom?
False means you shade the opposite side. So if the point's on this side and the line's here, you would shade the opposite side. If this was true, you would shade the side that's true.
Okay.
So shade the side that gives you the true scenario. If you find a point that gives you a false scenario, go to the other side of the line. Does that make sense? Good question. Can I move on? All right. So this problem set up in the way to use what type of method? Cover method. I like it. Okay. Before we start to do this, Matt, do you think it's solid or dotted? Dotted. Why do we think it's dotted? There's no equal sign. So this is definitely a dotted line. I like it. It's going to be a dotted thing. So if I do the cover method, I get 4x equals 12. So 4x equals 12. What's x equal to? 3. So I'm going to go 1, 2, 3, put a dot. Still with me?
Yeah.
And then I cover up here. I got negative 4y is equal to 12. So what is y equal to? Negative 3. So in the y direction, I go to negative 3, 1, 2, and 3. And do we say it was solid or dotted? I forget. Dotted? What point looks like a really good point to pick right now?
0, 0.
0, 0. 0, 0 is definitely on the top portion of this line. If If 0, 0 gives us true, we're going to shade to the top portion of this line. If 0, 0 gives us false, where do we shade? On the bottom. So 0, 0, great test point. And again, if the line goes right through the origin, don't pick 0, 0. Pick something else. So you could pick something way out here, or over here, or up here, or here, or in the regions. It's your choice. But I'll pick those, and I guess so I get 4 times 0 minus 4 times 0 is greater than 12. 4 times 0, 0 minus 0 is greater than 12. Is 0 greater than 12? No, this is false. So that means any point that I pick up here, any point that I pick up in this region gives us a false. Any point that I pick below here is true. And here comes that kid again. I'm going to shade everything. I was good at coloring. Got a 3+ in kindergarten. You ever wonder why your grades changed from a numeric value to a letter value? It's like, hey, I got B's. I got 3s. Good. What's that? So look good so far? Am I doing okay?
Yeah.
All right.
Can you pick another point just to show that?
Yeah, so so you want to pick a true point? You want to pick a false point? So let's pick that, 0, 10. Is that okay? That's up there. So if I pick 0, 10, I get 4 times 0 minus 4 times 10 greater than 12. So negative 40 is greater than 12. That again gives me false. But if I pick down here, if I pick like that, that would give me a true. So all of these down here give me all trues, no matter where I pick underneath. Okay? Can I move on? Whoop, almost done. Hey! What kind of line is that? Solid line, okay, good. It's solid. So it's not dotted, I like that. What else? It's who said that? Yeah, it's a vertical line. This is straight up and down. 1, 2, 3, 4, and 5. Okay, so this is a solid line that goes straight up and down. Now, these are pretty easy to do. I don't really have to pick a test point. I just have to pick a test region. What values do you think would be less than 5? 4, and 3, and 2, and 1, 0, negative 1, negative 2, negative 3. So the region all over here, and this is where the kid really starts coloring in. What do you think? Everything I pick over here. Now here comes the question some people might come across. Let's say you'd pick this point right here. I don't know, this point is like negative 3, 8. I don't know, I'm just trying to eyeball it. We're just taking an estimate. I'm not trying to be exact. So I have an x and y value up there, but I only have an x for my equation. So what do I use? Do I worry about the y component? No. I take this as my test. Is negative 3 less than or equal to 5? No, that's false. Or it's true. Jeez. Knew I shouldn't have gotten on the roof yesterday because after I fell off and I fell off. So that's true. Negative 3 is indeed less than 5. So any of those points that I pick over there, I look at the x component of it, and that's what I test. If it was y only, it would be a horizontal line. Okay, and the same rules apply. Oh, wait. What kind of line? Horizontal, and it's? Dotted. Horizontal line, dotted. So 1, 2 tree, dotted. Okay, I could pick 0, 0 as my test point. Which 0 am I using?
Oh, the second one.
The second one. I'm looking at that one. So is 0 greater than 3? What do you think?
No.
That's false. So I need to shade above. Go boo. Woo, almost done. Oh, I'm so close. One slide left. Can we make it? You ready? Here we go. Woo! All right. Uh-oh. Solid or dotted? Both. Dotted. Okay? Which method should I use to graph it? Cover. X equals 1, 2, 3. Y equals 1, 2, 3. Dotted. Almost 4. Good test point would be. I like it. And again, if it goes right through 0, 0, don't use 0, 0. Use another point.
Oh, shaded.
So 0 plus 0 is greater than 3. 0 greater than 3. True or false? False. So where do I shade? Do I shade down here?
No.
No, I shade up here. This is my true region.
You always shade the true region.
You want the true region shaded.
Okay.
Make sense? Everyone with me on this? All right. So, guys and girls. All right. I would like you to do page 112. And there's 7 problems there. And then what we're going to do after that is tomorrow I will first start, once we go over those, tomorrow in class, we will do in class page 113 and page 114. That I will do these in class. So let's have this done by tomorrow. I'll practice this. Hey, how many weeks of school are left? 3 weeks. So, yeah, the last week is like some weird schedule. So we have 2 solid weeks of this class left, and then there's a Monday, I think it's normal day, and then like either Monday, Tuesday, or Wednesday we would have, or Thursday we'd have this class or something. Yeah. No one has school Friday. You might, depends upon your period. It's based on your period.